Now I'm going to do the top part of this worksheet as fast as I can. So where I'm going to go with this is calculate the price, the elasticity of demand coefficient for Avengers posters. The nice thing is I've already done this work. Let's go to Avengers posters. I already did this 1.25, 5, and that's it. Okay, so it's 1.25. I already showed my work. All right, which product has the most elastic demand? So elastic means it needs to be greater than 1. Whichever one has the biggest number is going to be the most elastic. 5 is the biggest number. 5 is the biggest number. I'll even be scientific and put coefficient. All right, inelastic just means less than 1. All right, so I'm right here now. Inelastic means less than 1. I'm looking for one that's less than 1. 0.8 is the only one. So it is going to be, 0.8 is Superman mugs. This time I'm going to use shorthand and just put answer 0.8 is less than 1. And here I forgot to actually say which product it was. So that is the Phineas, whatever that is. I don't know what Phineas is. Phineas. Cool. All right. Going on. Which product has unit elastic demand? What unit elastic means is just means that it is 1. So I'm going to find one that's 1. Batman flashlights. Equals elasticity demand coefficient. I'm just going to put C equals 1. All right, explain why stores will likely not put vintage Star Wars actions on for $5. All right, so we can think through this one very quickly. So they're not going to do it. So let's find vintage Star Wars. So vintage Star Wars is right here, and it is perfectly elastic. So what does that mean? Here's my demand curve. That means that no matter what you make the price, it's not going to change how many people want it. So if you're a firm, you want to make as much money as possible. So if you lower your price, you're not changing how many people want it. You are only changing how much money you get in, right? So you want to charge the actual highest price, the highest price possible, right? We're talking millions of dollars now. This is where you can understand where there's a once in a, only one that exists in the world, like the Mona Lisa. People, no matter what the price is, people are still going to want it. So, just for the sake of time, you heard my explanation because it is perfectly inelastic. Cool. All right. Now, assume one of the store's owners lowered the price to $16. This is going to be a revenue test question, which you could write down. I've got my revenue test questions. So what it is saying is the following. So first of all, let me find Phineas. Phineas, I know that it is elastic. It's elastic. So they are saying that if they lower the price, so I'm going to go to my rules for the revenue test for elastic. So here's elastic. Here are my rules. If the price goes up, revenue goes down, or if price goes down, revenue goes up. We can talk about what that means, but for now, let's just follow the rules. So they're saying that price is going to go down, which means the revenue will go up, right? So here we go. They will increase or decrease revenue. Increase, because it's elastic. I'm not going to write more because you just heard my explanation, so I don't want to waste your time. Because it's elastic. Great. Now we're going to read this article about how certain football stadiums in the United States have raised and lowered their prices. Okay, so it says, why does the pricing strategies depend heavily on the elasticity? Well, there's a ton of different answers you can do here, but first you kind of want to know, do you have an elastic or an elastic product? Okay, because if you have an inelastic product, well, then you can kind of charge whatever you want, right? So if it's inelastic, raising prices, I'm just going to put up arrow, prices doesn't affect AFF, number of buyers, much. Okay, if elastic, raising or lowering prices, will. Raising or lowering. And the whole point of being in business is to make as much money as possible. So you want to increase your revenue as much as possible. We can talk more about the revenue test a little bit later, but not right now. So I just want to get this video down so we can get going. All right, cool. So this one's a tricky question. You'd think that you need to put 53 over 53, but you don't. We're going to use the formula where it's the percent change in quantity over the percent change in money. All right, so if the price, so that's going to go on the bottom. Okay, so I'm just going to, so the price is on the bottom, 53. Ooh, and actually I'm not going to write 53. Okay, so I'm just going to write anything because it says decrease by more than 53. So I could choose 54, I could choose 55, I could choose 90, doesn't matter. I will do, I don't know, let's make it 60 just to make a point. So I'm just going to change it to 60 because it's more than 53. Then on the bottom it's going to be 53. Well, I can do the math. 53 divided by 60. I know the answer is going to be less than 1. It's going to be 0.88, 0.88. So using my rules, it's going to be relatively inelastic because it is less than 1. Relatively inelastic. Because my answer is less than 1. Cool. Now, what do you think would happen if more vendors came to the stadium? So if more vendors came to the stadium, what do you think would happen? Okay, well, that one's kind of common sense. So if there's more competition, now you got to fight for your customers and you have to, right, you're probably going to lower your prices. Not only that, but you have a different type of nachos. So now there's other substitutes, or they're talking about hot dogs and you consider nachos as a substitute. So it'll become more elastic because more competition and more substitutes. Great. I will put a picture specifically of this in the Google Classroom.